a function is defined by f of x equals 3x minus 1 squared minus 18. Write f of x in the form ax squared plus bx plus c, where a, b, and c are constants. Okay, now there's more to the question, but that's the part we want to start with right there. So on your paper, jot this down and let's see what we can do. A, B, and C, ax squared plus bx plus c. And I'm going to let you talk to me and tell me what's going on and how we do this. All right, ideas?
So we use those numbers to write it basically in like that form?
Kind of. So what it's telling me is that we want my answer to end up in that form. We don't need to use these numbers right here necessarily, but we need to end up with this problem right here. We want to see what A, B, and C are going to be when we turn it into this form right here.
Would C be negative 18?
No.
Dang it.
I know, that's a really good assumption. I like that. I like that you're thinking it, but that is not correct. I can't even pause it. What is going on? Okay, let me see. I'm going to open this real quick. All right, so we're not seeing this anymore. Okay, so, not yet. There we go. All right, so you guys, here we go. So here's what I've got. A function is defined by that same function, and we want to write f of x in general form. And we said general form meant ax squared plus bx plus c. Okay, and then they told me that a, b, and c are going to be integers. Cool, awesome, fantastic. How do I turn this into this? Oyeda, idea? What you got? We need to expand. So if I look at this right here, this is already in vertex form. So what we need to do is we need to figure out how we expand this. We're going to use my order of operations. So what comes first? The x minus 1 squared. Yes! Anytime I have something being squared like this, all I have to do is square the first, square the last, multiply, and double. Right? Okay, so here we go. So let's start there. Inside of these parentheses, what is x squared? It's x squared. What is negative 1 squared? Plus 1. Now we're going to multiply those two together. What's x times negative 1? And double. Negative 2x. There you go. Look at us. We just did it. Minus 18. So there's my first part of the expansion. I took care of that squared. Now, order of operations. What do I do now? I'm going to distribute that 3. So now I'm going to end up with 3x squared minus 6x plus 3 minus 18. All right, so Jessica, tell me, what is C?
-15.
Negative 15. So do you see why it can't be negative 18, even though we wanted it to?
Yeah.
Yeah. Dang it. So now we end up with 3x squared minus 6x minus 15. So we took this original problem and we turned it into standard form, general form, whatever we want to call it. All right. Now, going to go to the next step. The next step said, hey, find the coordinates of the vertex. How do I find the coordinates of the vertex?
H and K.
It's H and K. Do I have this in the H and K form? You bet your sweet bippy I do. That's the way they started it, right? Check this out. This is my H and K form up here. So, what's H? What's K? Try again. What's H?
1.
1. Remember, it's inside the parentheses, so it's got to be the opposite. What's K? Negative 18. I love it. Uh-huh. Hang on. What am I looking for? Oh, there it is. Okay. So, the vertex is going to be 1, comma, negative 18. Now, I do want you to take just a moment, and I want you to see this right here, this write down. That means we shouldn't have to do a whole lot of math. If you have those words write down right next to each other, it means we should just be able to, bam-o, get that and figure it out. Okay? So now part C says, hey, write down the equation of the axis of symmetry. Ha, 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 ha. What do we know about the axis of symmetry for a quadratic? What kind of line is it? What kind of line is the axis of symmetry? It's a vertical line. Yeah, that's what I meant. Sorry. So we want an axis of symmetry, which is a vertical line. And we know that that vertical line is always going to be written in the form of x equals and then a number. How do we know what number to pick? How do I know what my number is for my axis of symmetry?
It's H.
It's H. It's whatever the beginning of my vertex was, right? Because whenever I draw that axis of symmetry, it has to go through the vertex point. Sergio, question?
No. No, sorry.
I saw your hand raised. You can ask. We won't laugh.
No, I accidentally clicked it on accident.
All right, Jackson.
I clicked it on accident.
All right. So here we go. So that means x is equal to 1. Nice. I like this. Okay. All right. And then we're going to scoochie on to the next part. Now it says, hey, the graph of f is translated to -1 to form the function g of x. Yeah, this is beautiful IB wording that tries to trip us up and get us all confuzzled. Okay, so it says the graph of f is translated to -1. That's a 2. That's a -1. Because that's how we write translations. Whenever we're moving it, we always write it in vector form. Remember that top and bottom, that's vector form. So that says we're moving it to -1. And when we do that, we get the function g of x. So here's what I've got. So you may have your brain that works beautifully and you know how to do this. I don't. So what I'm going to do is I'm going to start off with what I know. So I know, is this a happy parabola or a sad parabola? The original one, is it a happy parabola or a sad parabola? It's a happy parabola, right? Do we know where the vertex of that parabola is? We do. Do we know where the axis of symmetry is? Yeah.
Yes.
So where's my vertex? Go to the right one, to the down 18, right there, right? I've got an axis of symmetry doing this. Boop, 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 boop. It's got a 3 in front, so it's kind of a skinny parabola, right? Doo, 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 doo. I don't even need numbers on here to help me out. Okay? When I look at my translation right here is 2, -1. What does that mean? What does that translation of 2, -1 tell me to do? All right. Remember, in translation world, the top number always tells me left or right. The bottom number always tells me up or down. So this right here is translation. This is not function notation. So that's a +2. So that tells me to go to the right 2 times. Okay. That -1 tells me to go to the down 1 time. Now, if I need to do all of that moving, that means every single point on this graph moves. Every single one of them. If every single point on the graph moves, we know that means the vertex is going to move. So this vertex right here is at 1, -18. But what happens if I move that vertex to the right 2 and down 1? Where does it go? Can you tell me that ordered pair? 3? Try again. So we went to the right 2 to the down 1. So that 1, -18 now changes to be the point 3, -19. What is that going to change so that I can now write my equation in this form right here? That changes my h and my k. So what can I write down to help me out? I can put it in vertex form. So I know that g of x is going to be equal to what? Let's write this down in vertex form. Somebody tell me. 3, parentheses, look at that. Look how Yenda comes to class today and she is on a roll. Look at her go. She is saying, hey, check me out. I'm going to change my h and k from up here. Instead of being 1 and -18, I know that it is now 3, -19. Can you take this and write it in general form like this? No, I don't want you to do it right now. This is the very first thing you have to write down to submit to me for your assignment. Okay? All right. Now, here, let's look at problem 2. So I'm going to put a little star next to that. That's the first thing you have to submit for your assignment. Here we go, number 2. For each function, I want you to find the equation of the vertical and horizontal asymptotes, and I want you to tell me the domain and range for these two right here. All right, I'm going to press pause because I'm going to let you guys talk to each other for a minute. Okay, so we said that we have to find a vertical asymptote because that is when my function does not exist. The only times my function does not exist is when the denominator equals 0. Okay, so I'm going to take this one for my va, and I'm going to say that occurs whenever x minus 2 equals 0. And x minus 2 equals 0 whenever x is 2. There's my vertical asymptote. Wow. What about for b? How am I going to find a vertical asymptote over there? I'm going to do the same thing. For my va, I'm going to say, hey, that happens whenever 2x plus 4 equals 0. So then I get 2x equals negative 4, which tells me x equals negative 2. Wow. Now how do I find a horizontal asymptote?
Isn't it like you have to find the same, like for b, for instance, it would be 8x over 2x, or like 8 over 2?
Yes! Yes. So looking at b, that one's a little bit better to find the ha, right? So we said, hey, my horizontal asymptote occurs whenever I have the same highest power on my x's. So that becomes 8x over 2x, which we know we can reduce to 8 over 2, which then reduces to 4. So for part B, my horizontal asymptote is going to be at y equals 4. What, Oyenda? We take the we look for my x's when I have an x in the numerator and denominator. We look for the highest exponent, and this one's only a 1, so that's pretty cool. And then we set up a ratio using those terms right there. And so we end up with 4. Okay, now on part A, my horizontal asymptote's a little bit different because I don't have an x in the numerator and in the denominator. So this one, I have to dig into my brain, and I have to dig into the world of what happens when we have a reciprocal function. Remember, for this one, I only have an x in the denominator right here. So this one, my horizontal asymptote, has to take into account what's going on in the graph. If you remember, for my function y equals 1 over x, I know that that looks like this, whoop, and whoop, like that. And I know that I have asymptotes right here on the y-axis and right here on the x-axis. Okay, so I have the vertical asymptote would naturally be for the parent function. The vertical asymptote is x equals 0, and the horizontal asymptote is y equals 0. In this problem right here, we found that vertical asymptote because we shifted this guy 2 units to the right. For my horizontal asymptote, I have to take into account the other thing that's happening here, and that is that my entire function is getting shifted 3 units to the up. So for this problem, we're going to say that my horizontal asymptote is going to be y equals 3. All right, so your job on number 2 is to tell me the domain and the range for each of these functions. Okay? That's your job. All right, number 3. I want you to solve those 2 equations. That's your job on number 3. You know how to do that. You are good to go. So jot those 2 equations down. You're going to submit those to me. Okay. And we have gone way over our time online, like way over, like a whole Jackson story over. So what I am going to ask of you is I want you to submit to me. I'm going to make a Google Doc and post it in there with this video right here. Your jobs right now, you are going to submit to me the g of x function for number 1. You're going to submit to me the domain and range for both of these on number 2. And you are going to solve each of these equations and submit those solutions to me. Okay? Those are your 3 assignments that go with this. And I have 2 more really good questions. I'm going to post them and let you think about them, and I want you to approach them and try. But if you are confused and don't know what to do on them, it's okay. Just tell me what you think you would do to start working on them.